Looking up at the starry expanse, you might wonder, does the universe ever end? Is there a border to this grand cosmic show? Or does it keep going on forever? Do other universes exist beyond our own? Today, let's explore the edges of our cosmic understanding as we seek answers to these profound questions. First, let's focus on what we do know. The universe, as we know it today, began with the Big Bang. In the blink of an eye, space expanded rapidly, giving rise to everything we observe. Stars, galaxies, planets, and even we humans, all emerged from this primordial chaos. But our view of the universe is limited by something known as the observable universe. This is the region of space from which light has had enough time to reach us since the Big Bang. Due to the finite speed of light, the observable universe has a radius of approximately 46.5 billion light-years. Therefore, any region lying beyond this boundary remains hidden from our view. However, the universe itself isn't limited to this observable region. Space has been expanding since the Big Bang, stretching the fabric of reality and pushing galaxies farther away. Consequently, the universe extends well beyond what we can see. But just how big is this region? To answer this question, let's first discuss the shape of the universe. You might intuitively think of the universe as flat, like a boundless plane stretching in all directions, but it could also be shaped like the surface of a sphere, or like a saddle. Surprisingly, the shape of the universe has a significant impact on its size. In 2013, the European Space Agency's Planck satellite conducted a precise measurement of the cosmic microwave background, the faint afterglow of the Big Bang. By analyzing the patterns in this cosmic microwave background, scientists gathered valuable insights into the shape of the universe. Their findings indicate that the universe is incredibly close to being flat. If the universe is indeed flat, it would extend infinitely. However, if it's curved, it would either resemble a sphere or a saddle. In either case, the universe would be finite, although incredibly vast. While the universe could hypothetically wrap back on itself, colliding with itself like bumper cars in an amusement park, scientists believe that this scenario is highly unlikely. One compelling reason for this is that the universe appears to be uniform in all directions. If it wrapped back on itself, we would likely notice signs of this repetition. Furthermore, a collision between parts of the universe would have left scars on the cosmic microwave background, which we haven't observed. These considerations strongly suggest that the universe is not closed. They also rule out the possibility of the universe being shaped like a saddle. Thus, we can confidently conclude that the universe is flat. But what does that really mean? Imagine you're standing on a flat, featureless plane. In every direction you look, you see nothing but an endless expanse of land. That's what it's like outside our observable universe. For all we know, it could stretch on forever. But there's a twist. The fabric of space-time is expanding, and with it, the very structure of the universe is changing. As space expands, the distance between galaxies increases. It's as if someone stretched the cloth on which the galaxies are embedded, pulling them apart. In this ever-changing landscape, the notion of an edge becomes somewhat elusive. An edge would imply a boundary to this expansion, but the universe doesn't necessarily have one. It's not confined to a particular region. Rather, the universe is everything. The expansion of space means that it's constantly growing. Some areas of space are receding from us faster than others. Those situated in the outermost regions of the observable universe are drifting away at speeds exceeding the speed of light. This means that these distant regions will become permanently unreachable as they cross the cosmic horizon. From our perspective, it's as if a wall is being erected, blocking our view and preventing any light from passing through. These regions will essentially vanish from our sight, leaving us in a perpetual state of darkness. The notion of an edge or a boundary to the universe poses a profound philosophical question. Are we truly alone? Are we the sole inhabitants of this vast cosmic expanse? If there were other universes existing alongside our own, they might harbor life forms vastly different from us. These extraterrestrial beings might have their own unique perspectives, values, and ways of understanding the cosmos. When contemplating this vastness, it's essential to remember that the universe doesn't expand into anything. Instead, it expands in such a way that space itself increases. Think of it like blowing up a balloon. As the air inside expands, the balloon stretches, and the dots drawn on its surface move farther apart. It's not as though the dots are moving across a pre-existing surface. The surface itself is being created as the balloon expands. Similarly, the universe expands, creating more space as it does so. Therefore, the question of what lies beyond the universe doesn't hold. It's like asking what lies beyond a balloon's surface. The idea itself lacks meaning because the universe is everything. Now let's shift our attention to the concept of the multiverse. This idea proposes that beyond our observable universe, there might exist multiple universes, each with its own set of physical laws and constants. The existence of multiple universes raises intriguing questions about the nature of reality. How many universes might there be? Are they similar to ours? or vastly different. Can these universes interact? Unfortunately, the multiverse remains firmly in the realm of speculation. There's no direct evidence to support its existence. It stems from certain theoretical frameworks such as eternal inflation and string theory, but these are highly complex and currently untestable. Let's delve deeper into eternal inflation. This theory suggests that our universe is just one bubble in a vast sea of universes. Each bubble represents a self-contained universe with its own physical laws and constants. These universes are said to exist simultaneously, coexisting within a larger multiverse. The idea of a multiverse challenges our conventional understanding of reality. It suggests that there could be countless other universes beyond our own, each with its own unique characteristics. Some of these universes might have slight variations from ours, while others could be dramatically different. It's important to note that the multiverse is a highly controversial topic within the scientific community. Many physicists reject it outright, as it contradicts the principle of scientific parsimony, which suggests that the simplest explanation is usually the best. The idea of a multiverse also faces challenges regarding falsifiability. In essence, this principle states that a scientific theory must be capable of being disproven through observation or experimentation. However, the multiverse is so inherently speculative that it's difficult, if not impossible, to devise any conceivable way to test or disprove its central claims. The concept of brane worlds arises from string theory, which posits that the fundamental constituents of the universe are tiny vibrating strings. These strings vibrate at various levels, giving rise to the different particles and forces we observe. According to string theory, there could be as many as 10 or 11 dimensions, but we only perceive 4. Branes are hypothetical, higher-dimensional objects that play a significant role in string theory. They serve as the source of gravity and can act as the boundaries between different universes. The idea of brane worlds suggests that our universe is a three-dimensional membrane, or brane floating in a higher-dimensional space. These higher dimensions could host other branes, which in turn could represent other universes. The brane world model presents an alternative to the traditional view of the universe as a flat, homogeneous space. It introduces the concept of extra-spatial dimensions and challenges our understanding of the nature of reality. These multidimensional spaces raise questions about the origin, evolution, and ultimate fate of our universe. The search for evidence of these extra dimensions continues, with experiments like the Large Hadron Collider seeking to unravel their secrets. However, despite extensive efforts, there's no direct evidence of branes or other universes. So as we contemplate the vastness of the universe and the mysteries it holds, it's essential to acknowledge the limitations of our current knowledge and the boundaries of our understanding. The true extent of the universe may forever remain unknown, and the concept of a multiverse, while fascinating, remains purely speculative. Our journey to understand the cosmos is an ongoing one, and we must embrace the unknown as we continue to explore the wonders of the universe. What do you think? Does the universe have an edge, or does it stretch on forever? And what do you think lies beyond our universe? Share your thoughts in the comments section below. Also, please subscribe to our channel to keep learning. Thank you for watching.